Hello, Pre-Algebra. This is Mr. Giomini, obviously. If it wasn't me, I don't know how this video would get on the blog. Anyways, I wanted to discuss a couple questions today because we're not going to be able to meet about homework from the other night from Monday evening that I assigned for Monday, and some of you may be working on tonight, although most of us you'll have the concert to this evening. So I wanted to put this on this morning, get you a little head start, so tomorrow we meet on Wednesday. We can kind of hopefully iron out some of these questions beforehand. Oh, you don't need to know about that. So if I look at the, this is question either 1 or 2, I believe, and I'll go through a couple others. So take a look at question number 1 or 2 here. It says, and before I do that, remember, a permutation, the order matters. Combination, the order doesn't matter. So permutation, the order matters. So whatever order I put it in, that matters. Where a combination, it doesn't matter. So if I'm picking out clothes and I'm matching shirts and ties and slacks and shoes, the order really doesn't matter. If I'm putting kids in a specific order in line based on, let's say, letters in their first name, and I want a specific, I want it alphabetically, then obviously that's a permutation because the order matters. So if I take a look at the example here, the question they give us, it says, if you had to match 6 players in the correct order for most popular outfielder from a pool of professional players numbered 1 through 49, how many possibilities are there? Now, I have 6 players, but the correct order, that should let me know now, right now, the order matters, and the order has to be based on most popular outfielder. And that order is 1 through 49. So I'm taking the 49 most popular players. So this is a permutation. So order does matter. So remember, we're doing a permutation. It's n, number of outcomes, over how many I'm ordering it into, the number that I'm chunking them. So I have, remember, it's how many outcomes, n factorial, over number of outcomes minus how many I'm choosing, or how many I'm chunking them into, factorial. So for this, I have 49 outcomes divided by, or over 49, because that's how many outcomes are. Now I am chunking into the 6 that I want, and again, because it's the correct order, I know it's a permutation as opposed to a combination. So, and that's factorial. So we know that this is 49 factorial. 49 minus 6 gives me 43. So I have 49 factorial over 43 factorial. Now again, I can write 49 times 49, or 49 times 48 times 47 times 46 over 43 times 42 times 41. But remember, everything from 43 on down or fewer will cancel each other out. So I'm just going to go I'm going to do it down below here because it won't be able to fit here. So I'm going to go 49 times 48 times 47 times 46 times 45 times 44. I don't include 43 because when I have 43, that'll cancel out the 43 up here. So 49, 48, 47, 46, 45, 44. So if I plug this in my calculator, 49 times 48 times 47 times 46 times 45 times 44, I get this answer: 1 0 0 6 8 3 4 7 5 2 0. Throw my commas in here. 10,068,347,520 possibilities when I order those 6 most popular players. All right. Now, I received an email last night. I'll keep the person's name anonymous, although I thought it was great that they emailed me and said, "Hey, Mr. Jimmy, you know what? I'm getting the answer, and I'm checking my answer, but I'm not quite sure how I'm getting this answer." Good question. You know, I gave you the answers yesterday. They're on the back side, so it's easy to say, "Oh, well, I don't understand this. I'll just write this answer down." So let's take a look at this problem. So volleyball tournaments often use pool play to determine which teams will play in the semifinal and championship games. The teams are divided into different pools, and each team must play every other team in the pool. The teams with the best record in pool play advance to the final games. Okay, so some of you that play sports, or many of you play sports, you may have been in a tournament or something like that. So this is kind of like, and again, it's not based on records, you just put into 2 different pools. So if I look at the first one here, number 3, if 12 teams are divided into 2 pools, how many games will be played in each pool? Now here, order does not matter, so this is a combo. This is a combination. The order does not matter. So if I'm taking the 12 teams and putting them into 2 pools, I'm actually going to have 6 teams, and 2 teams are going to be playing each other. So we have 6 factorial over how many teams will be playing each other? 2 factorial minus how many teams are there? 6 minus the 2 teams that are playing each other, factorial. So if I take a look at this, it becomes 6 factorial over 2 factorial times 4 factorial. Alright. Now, if I want to think about this, again, I could simplify this. Can I skip a step here? This would give me 6 times 5 times 4 times 3 times 2 times 1. Now, I'm going to look at the larger number. That's 4 times 3 times 2 times 1. So that's going to cancel everything out that's 6 and 6 factorial and this 4 factorial have in common, which is 4, 3, 2, 1. So all I'm left with on top is 6 times 5, because the 4 will cancel out with this 4 and everything less than that. And I have 2 factorial, which is 2 times 1. So I really have 30 over 2, which is equal to 15. So there will be 15 games played in each pool, or a total of 30 games. If I look at number 4, okay, now we have 12 teams, but they're divided into 3 pools. So if I divide 12 by 3, I get 4. So how many combinations are there? There are 4. There's going to be 4 teams in each pool. And again, it's 2 because 2 teams are playing each other. So I have 4 factorial over, now, how many teams are playing each other? 2. Alright, how many teams are there all together? There's 4 in each pool, minus 2 because there's 2 teams playing each other. So now I have 4 factorial over 2 factorial times 2 factorial. Alright, so I have 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. These cancel each other out, so I'm left with 4 times 3, which is 12, over 2 times 1, which is 2. 12 divided by 2 is 6. There's going to be 6 games played in each of the 3 pools, so a total of 18 games. Alright, if I take a look at one more, I think I have one more. Okay, how many possibilities are there for a jumble with 6 letters? Okay, I am not looking for a specific order. It doesn't say correct order here, so I know I can deal with, I'm just dealing with 6 factorial because I'm just taking 6 letters and how many different combinations can I get? So it's really just 6 factorial, so it's 6 times 5 times 4 times 3 times 2 times 1, or I could do the Samantha Cole method and eliminate that 1. 6 times 5 is 30. 30 times 4 is 120. 120 times 3 gives me 360. 360 times 2 gives me 720. So there's 720 different possibilities. Hope this helps. Take care.